Hello, calculus students. In this problem, we are to determine the lengths of two diagonals of a parallelogram created by these two vectors. All right, what I've done is I've taken the liberty to draw the parallelogram out. Here's v, which is minus 6, 0, and here's u, which is minus 3, 3. And what I did here is I remember that vectors that are parallel and have the same length or magnitude are equivalent vectors. So that's how I created these sides of the parallelogram. And then we have something called the parallelogram law, and I'm going to try to convince you of this law just with this example. What I'm going to do here is draw this vector here, and my claim is that this vector is u plus v. And if you look at what we've done here, to create u plus v, you notice that the x coordinate here, the x component, this has length 3 here. So that means that this got pushed over from minus 6, got pushed over 3 units. So this component is minus 6, and then you shift it over to the left 3 units, and that gives it a minus 9. And then, of course, it hasn't changed in the y component, so it is minus 3. And if you look and you add u plus v, if you add their components, minus 3 plus minus 6 is minus 9, minus 3 plus 0 is minus 3. Now, this is by no means a proof. It's just a justification via this example. But that is the parallelogram law. And if you have two vectors lined up like so, and you draw the diagonal of the parallelogram, it is the sum of the lengths of the parallelogram. Okay, well, now that we have this vector here, and this is u plus v, we could very easily determine the magnitude of u plus v by taking the square root of the sum of the components squared. And if you work that out, you'll see that that is the square root of 90. All right, now we'll move on to the other diagonal, and I'm going to redraw the picture for that example. Okay, here for the other diagonal, what I've done is I've taken v, which remember, I'll just draw the arrowhead, was out over here at minus 6, 0. This was v. But if we go in the opposite direction, we put a minus sign in front of it. That changes its direction. And then we distribute that minus 1 into the vector. And that scalar multiplication gives us, scalar multiple gives us a positive 6, 0. And then once again, I'm simply going to apply the parallelogram law, as I did in a previous example. Here we have u, and we add the other side, but that is minus v this time. So the diagonal in this case is u minus v. And if I just drew the parallelogram here off to the side in its original configuration, and then I took this vector here, u minus v, and I connected it here. Okay, so you would see v here, u here, and then the vector u minus v would be the connecting that triangle there. But anyhow, continuing with our problem, we can now easily compute the magnitude of this vector, and all I have to do is just subtract the components. So let's see, u minus v is minus 3 plus 6, and minus 3 minus 0, and that has components 3 minus 3, and that will have magnitude 3 squared plus quantity minus 3 squared, and that is 9 plus 9, and that is the square root of 18. So those are the magnitudes of each of the diagonals of the parallelogram. The one going to the right is u minus v, and the one going in the other direction, maybe I'll put it in black here, in this direction here, that is u plus v. All right, good luck.